Hi guys, welcome back. In this video, we are going to discuss about biasing of diodes. First, we will discuss what is meant by biasing. Biasing means the process of applying external voltage is known as biasing. The process of applying external voltage is known as biasing. If a diode is over there, the process of applying the external voltage, I mean that connecting to an external circuit, this is known as biasing. If you apply some voltage, this configuration is known as biasing. Just see, this is the representation of an PN junction diode. Here, this line represents the N side and this arrow indicates the P side. Remember this. This is what I forgotten to mention in the previous video. And in PN junction diode, in in PN junction diode, just think of this as a magnified version of PN junction diode. We will have what we call uh, just consider this is half. This is P type and this is N type. In P type, we discussed that in P type we have positive electrons, and this is the region where holes are the uh, most dense in condition, and here electrons are most dense in condition. Just consider this is the what we call partition layer, right? Just consider a layer, just adjacent layer, just an adjacent layer to what we call just an adjacent layer on P side and N side. We have positive type ions. These are bonded with another positive ion in another layer, adjacent layer, right? Here we have electrons. These are bonded with adjacent electrons. To break this bond, we need certain voltage, certain energy. That voltage is known as forward bias voltage that we discussed, right? 0.3 to 0.7 volt. Why we need to apply minimum this much of voltage is we have to break this bond between adjacent layers so that the electrons can pass from this side and positive ions can pass from this side so that current flow passes through the diode. As we know, the current will flow in the opposite direction of electrons. Electrons will flow from this side to this side. So current will flow in this direction. Yeah, that is the reason behind maintaining 0.3 to 0.7 voltage. Now let's discuss about type of biasing. We have three type of biasing. One is zero biasing. Good is forward. Another one is reverse. First, we will discuss about zero biasing. Zero biasing when there is no external voltage applied on a PN junction diode called zero biasing. Zero bias junction diode. That's what I mentioned, right? However, if the diode terminals are shortened together, a few holes in P-type material with enough energy to overcome the potential barrier will move across the junction against the barrier potential. If that means if you are going to connect both the diodes to, I mean, both P-type and N-type to a same terminal, it will receive some amount of ghosting, what we call ghosting voltage, which is enough to break this potential barrier. This is also known as barrier, potential barrier, because we have to overcome this barrier, right? For flow of current, we have to overcome this barrier. If we are able to break this, then current will flow, right? That's what he mentioned. It is all. This is known as forward current. A and reference as IF. Just mark these notations. We are going to use this notation throughout our course. IF in the sense forward current, IR in the sense reverse current. F represents a subscript of F represents forward for everything. Subscript of R represent reverse. It might be voltage, it might be current, it might be resistance, anything might be. Okay, we distribute. Likewise, holes generated in N-type material, minority carriers, move across the junction in the positive opposite direction. This is known as reverse current. It is represented as IR. That's what I said, right? IR. This transfer of electrons and holes and forth across the p-n junction is known as diffusion. This is the phenomenon that I explained. Movement of negative electrons to p side and movement of positive ions to n side is known as diffusion. That's what I mentioned. Whole thing. This is the representation of an p-n junction diode, and this is a circuit representation. Just have a basic idea of these things. Uh, and now we will going to discuss about forward biasing. Forward bias p-n junction diode. When a junction is connected in a forward bias condition, Forward bias condition. These are the forward bias conditions. Negative is negative is connected to n type, and positive is connected to p type. This configuration is known as forward bias PN junction diode. Just remember this. Don't forget this. This is the whole point of forward biasing. That's it. If the external voltage becomes greater than the value of a potential barrier, approximately 0.7 voltage for silicon and 0.3 voltage for germanium. That's what I mentioned in my previous video. It's not 0.2. It's for an typical germanium diode. It's 0.3 volts. And I discussed about 0.7 and 0.3 in previous slide itself. The potential, what is meant by potential barrier also in the previous slide itself. The potential barrier opposition will be overcome and current will start flow. Okay. I hope you guys got the for what is meant by forward bias. If you're going to connect, this is to positive terminal. That's what I'm drawn in the previous diagram also. And n type to negative terminal. This is known as forward biasing. In forward biasing, with even with an voltage, if you are going to maintain even less voltage, just like 1 volt, then the circuit will run the current. And this is the characteristics of an PN junction diode in forward bias. Just see, up to 0.7 volts, we can observe only less amount of current is passing, because first of all we have to overcome that barrier. Then only the full current can be flown through the diode. Just see, after just crossing the 0.7 voltage, the current increased drastically, steep. The curve became very steep. That's what I mentioned. This voltage is also known as key voltage. KNE, knee voltage. Uh, the application of a forward biasing voltage on a junction diode results. What are the applications of a forward biasing? Uh, the depletion layer will become very thin, narrow, which represent a low impedance path through the junction, thereby allowing the high current to flow. Yeah, I discussed it. In PN junction diode, just consider this is a depletion layer. If you connect this PN junction diode in forward biasing, then the depletion layer would become thin. It might become into this size. That's what I mentioned. And after, because of thin depletion layer, the current start flowing in a huge manner. The point at which sudden increase in current take place is represented on the static IV characteristic curve known as knee point. That's what I mentioned. This is the knee point. The minimum voltage required for an overcome the potential barrier is known as knee voltage. It's represented in this manner in an IV graph. Just try to remember this graph. If you're, it's somewhat important. Uh, the thin depletion layer. That's what this figure is related to uh, forward biasing. Now we will discuss about reverse bias PN junction diode. Reverse bias in the sense opposite to forward bias. In forward bias, we connected P type to positive, N type to negative. Now here, positive will be N type and negative will be connected to P type diode. Yeah, just look at this. When a diode is connected in a reverse bias condition, a positive voltage is applied to N type material and negative voltage is applied to P type material. That's what I mentioned. The positive voltage applied to the N-type material attracts electron towards the positive electrode and away from the junction, while the holes in P-type are attracted to away from the junction towards the negative electrode. Just look at this. This is depletion layer. If you are connecting N-type to positive and P-type to negative, instead of electrons flowing in this direction, it will start flow in this direction, because electrons will attract towards positive charges, right? Instead of uh, going across this barrier, it will start flow in a path where there is no resistance to it, right? It will start flowing in the reverse direction. It will start flow, start flow, start flow. and it will hit it. Slowly, slowly, the depletion layer will increase, right? All the holes are transferring from here to here, here to here. And all positive ions are transferring from here to here. Slowly, slowly, the depletion layer is increasing, increasing, increasing. Every time when an electron passes it and come and hits it, the depletion layer will become somewhat big. Consider when continuously electrons are coming and hitting this depletion layer, continuously coming and hitting, coming and hitting, coming and hitting, coming and hitting. At a certain what we call time, due to impact of this electrons itself, the depletion layer would break. In that condition, the whole electrons will pass freely. When this depletion layer breaks, that condition is known as breakdown voltage. Breakdown. What I mentioned is, if this flow of electrons in a reverse direction continues for a long time, just consider if electrons flow for a long time in a reverse direction, due to impact of electrons, the strength of this depletion layer would become weak, and the what we call velocity of electrons is far greater than velocity of positive ion. So the kinetic energy will be more for these electrons, and the impact force also will be very high on this layer due to flow of electrons. After certain time, it will definitely going to break. The depletion layer will definitely going to break because of impact of this electron continuously. The moment of breaking of this depletion layer is known as breakdown of an diode. From that moment onwards, the current will start flowing continuously without any resistance. The current flow will be very high. That is also known as reverse current. Now, what are the properties of an diode when connected in reverse bias? We will discuss that. The depletion layer grows wider due to lack of electrons and holes present in high impedance path, almost an insulator. That's what I mentioned. Right? The depletion layer will grow. The result in that high potential barrier is created, thus preventing current flow through the semiconductor material. Up to breakdown, the current will be zero, right? Because the electrons are not able to pass through this depletion layer. Because of very thick depletion layer, till breakdown, the current flow will be almost zero. Actually speaking, there will be some leakage because of what we call non-homogeneous of these layers. I mean, semiconductors. For theoretical knowledge, we are considering it to be zero. A huge resistance value of PN junction diode practically zero current flow through the junction with increasing bias voltage. However, very small voltage, a small leakage current does flow through the junction, which can be measured in microamperes. That was mentioned, right? Here, something not mentioned is after certain time, the after certain voltage, if you are going to increase this voltage, the what we call velocity of electron will increase, right? After certain voltage, the depletion layer will break down, and the high current will pass through it. That is also a point to be marked over here, and I will show you the increase in depletion layer. There is no, I think I haven't attached any figure of this like what I mentioned here. Now, if you consider the full characteristic curve of an PN junction diode, both in forward biasing, both in reverse biasing, just see, if you are going to in forward biasing, if you are going to increase the voltage up to knee voltage, the current flow will be very small. After knee voltage, the current flow will be drastic, and this is what we deserve, and this is the purpose we made our diode, right? This is desirable. Desirable. But when we connect, we are not going to connect if unfortunately if we have connected our diode in a reverse condition, then up to certain voltage it's going to withstand the thing. After reaching the breakdown voltage like 50 to 70 volts, the diode is going to break down, and huge current is going to flow through the circuit, and which is going to be damage the whole circuit in future. And this breakdown is also known as Zener breakdown or avalanche region. These are both are two different things, and I will discuss about these things in a next video. I think this is up for this video, guys. Thank you. Meet you in the next video.